All right, welcome back everyone. We're going to take a few notes here today. It's based on this section of congruency. Today we're going to get a Google question of the day. So one question at the end of class. You'll have a little bit of time to work on it. That's probably the problem you'll need a calculator for. So I'll probably hand them out here in a little bit. So if you need one, just think about it for a few seconds if you need it. We're going to do a couple calculations. I'll show you. I have 3 problems kind of picked out today to kind of get you in that swing of things, like what you have to do, what you're going to be asked to do. So we're going to review a couple of the properties we did yesterday, and then get into our 3 problems. I have 3 that I'd like to cover today, and I already kind of have them ready to go. So I will go through those here in a second. So if you can, have your notes out. If you haven't put your cell phones in the caddy, do that now. And if you haven't signed up for Hot Lunch, do that now as well. So I know some of you tend to forget that. Make sure you sign up for Hot Lunch right now as I take attendance for the first few seconds here. I think yesterday I updated grades again at the end of class, or end of school yesterday. So if you were turning in stuff on Google Classroom, I think I went back and I updated a few things. So I know some people have. If you redid an assignment, just let me know that ahead of time. Like if you didn't you got like maybe a 4 out of 5, or you got like a 9 out of 10 or something like that, and you redid it because maybe you noticed that you messed up on something. You got to let me know that you redid it, because I don't know. If you resubmit it, I don't see that unless you tell me. So then I'll go back and I'll check it again. So just that's a word to the wise here. So but yeah, so let me go through a couple things here. We're missing a lot of people today. A lot. Seems like Zoom is working today. Zoom did not work for me yesterday. A lot of people were not being able to even see the Zoom yesterday. So I don't know what the deal was. It worked for like 1 class, I think, as normal. Let's see. Anyone seen Nick today? He's no está aquí. Okay, I think we got everybody else. Okay, excellent. All right. Boom. Excellent. Okay, all right, let's jump right in. All right, so first of all, let's kind of talk about what we're doing here today. We're talking about congruence. So in objects, it doesn't have to even be triangles, it just has to be congruency. So if you notice the title of the section, it doesn't even say triangles in it. So any objects, any type of polygon, so we talked about triangles, quads, we talked about pentagons, hexagons, any of those shapes, the polygons in general, they can be congruent to another picture. So don't feel like it always has to be a triangle in any of these cases. So it can be anything, any object, and they could be congruent to each other, equal in size, shape, and measure. One of the big things we're going to talk about today is what that means, and how do we use congruency to actually solve a problem out, to actually figure it out. So that's what we're going to be looking at. So Theorem 4.3 is the one we talked about yesterday, and 4.4 talked about, reflexive and symmetric and transitive. I'll go through those here in a minute. But my goal is to go through 3 examples to show you this idea of why this symbol here is so important. How do you look at it? How do you read it? What is it actually telling you? It's way more specific than you think it is. So there's an easy way of doing it, and I'm going to show you my little shortcut that I've learned over kind of the years of doing this. And the book doesn't really ever talk about this, but it's a shortcut, and it's based on what you're seeing here. When I write it down with the 2 objects being congruent to each other, by the way they write those letters, it's super important the order that they put them. It doesn't have to be alphabetical. It could be any order, but the order is important. So that's what we're going to talk about when we get to our 3 examples today. At least 2 of them anyway. All right. Questions with the congruency symbol. Equal in size, shape, and measure. Okay. Okay. All right. Let's jump in and let's take a look at our 2 theorems we had yesterday. So if you don't remember, Theorem 4.3, this is the exact work we did yesterday. You're given a triangle where 2 angles are matching with 2 angles of another triangle. So in this case, this was, I think, period 7's problem. They picked 6 and 1. You guys picked some small numbers too, but they picked 6 and 1 yesterday. So I put them in there. And then so the 3rd angle had to be a 173. And that's the same as the other triangle. So since 2 angles match the 2 angles of the other, you could transfer the 173 automatically to the other one. You don't even have to think about it. That works for angles, not walls, but angles. So keep that in mind. So, but yeah. So how we did that one, we noticed that triangles have to be 180. You could set the 2 equations equal. You could subtract the same numbers from both sides, and it works out where the 3rd angle had to match. So keep that in mind. because I didn't tell you in the beginning that these triangles are congruent. I didn't tell you that. I just told you certain angles matched. So the third angles also had to match. That only works for angles, so I can't stress that enough. All right, questions with Theorem 4.3. We're going to use this one today. I think it's used in almost every problem, but I think it's for sure it's used in the last example I do, the third example I'm going to give you today. So, all right, let's jump to the next one. This is the last property that we talked about yesterday. This is the reflexive, symmetric, and transitive property. This is where you could set up your equations and solve it later, where you can transfer things around the pictures. So you maybe notice that certain triangles are equal, congruent, I should say, and then you could flip the two around with symmetric or transitive. You could connect the dots between multiple triangles if you happen to notice that they have the same markings and whatnot. So. But those are the main ones. We're going to look at those more later. That's not today's stuff. Today's stuff is more that Theorem 4.3 and the idea of congruency. All right. So, questions with any of the stuff we did yesterday. Perfect. Good timing, Bronson. Good timing. Okay, let's get to our new stuff today. I have 3 problems kind of picked out, and I'd like you to write these down. So here's the first one. I'm going to let you write this out. I want you to draw it. Put the letters, put all the values in there. If you can't read something, sorry, I'll kind of fill you in. That's a 2x plus 11, a y plus 10, a 2y minus 40, and a 3x minus 9. So, and the 2y minus 40 got a little messy, but I'll let you write this down. The big thing is that thing up in the corner. This is actually the most important piece to this problem is this thing. Without this thing written in the corner, I would not be able to do this problem. I wouldn't be able to. I wouldn't know. There's no markings on these pictures, so I had to have that congruency item up in the corner, and we're going to talk about the importance of that thing here in a second. So, can't make it a. Oh, I can. There we go. That's what I'm talking about. Can I change the color of it? Aha! Excellent. New stuff every day. All right, so I'll let you write this out. Before we get to this one, who needs a calculator today? Who would like to borrow one? Okay, one. Anyone else? Just the one? Okay. Let me put my mask on here. Trip. Anyone else, Emma? No? Going once. Sorry. Sold. All right. Okay, let's talk about that item up in the corner. Now that I've given you a little bit of time, maybe you're still drawing, that's fine. Let's talk about that item way up in the corner that I put that little red box around. What does congruent mean again? What does that symbol mean? That little squiggly sign above the equal sign, what does it mean? What did we talk about yesterday? Size, shape, and measure. Everything. The walls, the angles, everything. Now, here's the thing the book never discusses. The order these letters are written, the order they're written in is exactly how you look at the picture and you assign what items are equal to each other. Okay? So, for instance, what I mean by that is I'm going to try to color code this as I go. So if you're colorblind, sorry, I'm just going to go off of what markings I make here in a second. So what I mean by this is that this angle L, so for the triangle we have an angle L there. It's L, M, and N, right? There's walls, there's angles. So that letter L, that angle L in that picture is equal to the first letter over here. So it's equal to angle R. So L and R are the same because it goes letter for letter. So if I make the marking on my triangle, angle L is equal to angle R. Do you see how it goes letter for letter? And then what's the second letter? Well, and I'll try to color code this again. The second letter is M. and the second letter over here is S. So M, this angle here, is the same as angle S up here. They're the same angle because they're found in the second letter position. So up there, I can actually set up my problem now. Now that I know M and S are the same angle because of that little stipulation up in the corner, I can go to my picture and I can see that M is a y plus 10 and S is a 2y minus 40. I can immediately set these equal to each other because this symbol allowed it, that congruency symbol. Does that make sense why we have that thing out in the upper corner? It's telling you letter for letter what you can set equal to each other. So when I start my problem, like what you're seeing, you're actually seeing me do like a normal problem. I'll look at the letters up in the corner if they provided those to me. Maybe they're in the instructions. And then what I'm going to do is I go look at the picture and I start making all my markings. So I do the angles first to see if there's any angle I can set equal to each other. So like on this one, I noticed that M and S have the same angle, and there was variables there. So I set those things equal to each other, and I'm going to solve this out. So let's do the math here. How do I solve this out for the y? What do I need to do? How do I solve that equation? Somebody walk me through it. What should we do? Please.
Subtract the 2y
okay.
from the normal y
yep.
and the 10 from the shortest.
Good, yeah. So you're going to move these items around. You're going to like move them and change their sign, right? You're going to subtract. So right now we have a 1y. We're going to subtract the 2y across. Like you said, we're going to bring the 2y over. Technically, we're subtracting it from both sides so that it goes away on the right side. And then we're going to bring that 10 over and subtract it from the negative 40. So we drag it over. It becomes a negative because you went across the equal sign. So what we have here, if we did this correctly, we have a negative 1y, so that's 1 minus 2, which is negative 1. And then negative 40 minus 10 more is negative 50. And what's the last step? Divide by a negative 1, right? Or just the shortcut, get rid of the negative signs. So if we get rid of the negative signs here, that's y equals 50, right? You divide it by a negative 1 if you want. Divided by negative 1, divided by negative 1. I don't know how you want to think of it. So, but we get 50, so that's my y. Now, if I want to find the angle, I can go plug that back in. So if it, maybe the question is, what is angle M? Okay, well, take my 50 and go plug it back into angle M. So, in fact, angle M ends up being a 60. If I plug the 50 back in for y. Okay, questions with that first letter there, the y. Okay, your question of the day looks really similar to this. So where I give you a picture, I tell you kind of a stipulation, you can go and solve for the missing parts. You just have to notice like what's written in the corner and go off of it. So that you know what to set up and what to set equal to each other. And then, obviously I'm going to keep going here. I think we're on a roll. The last one, the last letter here, that was N and Q. Those angles are equal to each other. So here's N and here's Q. Those are equal, and there's nothing sitting there. So I'm done with those. Okay, do we feel comfortable with the angle situation now? How I set those angles equal and how I set it up? Okay, again, letter for letter. Now, again, the book never discusses that. They want you to like what the book says is they want you to orient the pictures so like in your head you would like turn the pictures so that they could line right on top of each other, and when they line up on top of each other, then you can notice which letters match up perfectly. You have to be very visual and turn things and move them in so that they fit right on top of each other like a puzzle piece. So I don't like doing that because when you get to pictures like this, it's like impossible to tell, okay, well, what side was supposed to be matching? Because the triangles look the same anyway, right? They're not even drawn to scale. So it's borderline impossible to like orient the pictures so that you can figure out what lies on top of each other. Some people are really good at that. Spatial acuity, that's something that kids develop when they're really young. I don't know if you ever had that toy when you were younger where there's two different versions. There's like one where it's like a little red bucket and it's got a blue top and it's got cutouts on the top of it where it's got like a moon and a circle and a triangle, and you had the little yellow blocks and you had to fit them in there, right? Every kid had it. Some kids, like when they're younger, have a big ball looking thing. It's like a big plastic ball and it's got cutouts on the side of it, and it's got the little yellow pieces you can stuff in there like a puzzle, basically, and they fit into the slots and they fall into the object. It's to develop kids' spatial acuity, to see three-dimensional objects and like work on their motor skills, but it's also to help them like match up visual items. It's a developmental skill. It really helps with 3D imaging, that kids learn how to orient pictures so they fit together. That's why it's a big deal for like puzzles. Like when you're older, you always see like grandparents working with like little puzzles. It's to work on their motor skills and memory and visual acuity stuff. It helps mental abilities. It's really weird, the psychology of it. So anyway, I'm on a tangent. Let's keep going. All right, so the next part here. I want to take a screenshot of that. Okay, so the next part, now that we found y, the next part is now to do walls, right? We did all the angles. I always do the angles first. The next part is to do walls. All right. Ooh. I don't know what I just did there. Oh, there we go. All right, so do the walls next here. I must erase my letters. Okay, so the walls now are the next part. So how the walls work, and this is the next part. You have to look at the two letters back to back. So what I look at is I look at these two now. LM. That wall, LM, that's this wall right here, I'm going to mark it, is equal to the first two letters over here, RS. That's this wall. Two letters at a time. That's what makes a wall, right? It takes two letters to make a line. So LM and RS are equal, and I made those little markers, so now I can set those walls equal to each other. The 2x plus 11 is automatically equal to the 3x minus 9. And I can set those equal and go ahead and solve from there. Okay, does that make sense how I use the two-letter system? So it'll be the front two letters, and if there's nothing there, then you move to the back two letters, and if those aren't there, then you do the outside letters for the last wall, the LN and RQ if you needed to set those up. So now to solve, I'll just kind of walk you through this one because I think it's pretty much the same as the last one. I would subtract the 11 across, I'd subtract the 3x across. So 2x minus 3x. I have the negative 9, I'm going to subtract the 11 across. So this ends up being a negative 1x and a negative 20. So my x ends up being a 20, positive 20. I divide by negative 1. Then if I needed to, maybe the question was, well, what is the length of R to S? Okay, well, take my 20 and go plug it back in. So it's going to be 60 minus 9, which is 51. If I had to plug that 20 back into RS. Okay, questions with what you're going to be asked to do on your Google question of the day today, where you set certain parts equal to each other. Okay, let's do one where it's not a triangle. I picked triangles here. Let's get away from the triangle situation. Let's do something like bigger. Let's do like a quad of some type. So that way you get to see like how this stuff works for bigger pictures. So second to last problem here. I only have one more after this. Okay, so we have a polygon. They don't even say it's a quad. They just said polygon. Polygon BCDE and then polygon RSTU. And we have a bunch of variables here. We have an x, y, a w, and a z. And we have to see how to set these things up. Again, don't just look at the picture and go, well, these two are w's and these two are y's, and don't do any of that. Go off the letter system up in the corner. So whatever they tell you. So I'll let you write this one out. Let you draw this, make the markings on it. I only have one more picture after this, and then I'll turn you loose in your Google question of the day. The next one's way easier than these. Like I picked, like these first two were kind of overloadedly kind of difficult, but the next one is super simple. It's just got one part to it. Some of you are still drawing, writing.
Is that a 2 or a Z plus 16?
For where? Where are we at? Up by the UT part. That's a Z plus 16. Yeah, good question. That's a Z plus 16. Okay. I may not finish this problem all the way out, but I'll at least get you pretty good and started, just so you can get to see this. I know some of you are still drawing in this and kind of labeling, because there's a lot of stuff here. This is a pretty traditional problem. Okay. I know some of you are still drawing, that's fine. I'm going to just put a box around that label up in the corner. I need to look at those letters, so I'm going to put a little box around it. So, all right. All right, so this is the part that I want to look at right up here. Let's make this a really bright blue color. Okay. Okay, so I'm looking at this polygon B, C, D, and E. I'm going to go off the angles first. I know this seems tedious. I always do angles first, then after I'm done with the angles, I'll do the walls next. So angle B is equal to angle R. So I'm going to go letter for letter. So this first letter here, B, is equal to R over here. Letter for letter, in order. So angle B is this one, and angle R is this one. So I can immediately solve for X. Because what I have here is a 2x plus 9, that's angle B. That's the angle that's sitting in the corner. That's equal to the 49 for angle R. And then I can go ahead and solve. Right? I would subtract the 9 across. Whoa, I'm erasing stuff. I would subtract the 9 across to get 40. Right? So subtract the 9 over. Then the last step is divide by 2. Right? Divide by 2, divide by 2. My X is 20. Letter for letter. So like it's meant to be quick. The way that I do my problems, I always do angles first to get those out of the way so I don't have to think about it too hard. Letter for letter. So I did the first letters, now I do the second letters. So C and S, I don't have anything in C and S position for the next one. So that's the second letters here. I don't have anything in there for C and S. That's this angle and this angle. Nothing sits there, so I can move on to the next part here. I would go on to D and E, D and T, sorry, D and T. And yeah, D and T actually have stuff sitting in them. So if I look at that next one, so here's angle D, that's the third letter, and the third letter over here is T. Well, D is this angle right here, and T is this angle. So the 2y minus 31 is equal to the y plus 11. Then you go ahead and you solve that one out. Okay, this ends up being, I think, a 42, if I'm not mistaken. That's what y ends up being, if you did the work. Now, if I wanted to, I could go plug it back in, figure out what the angles are. I think those are pretty much all the angles now, because E and U don't have anything matching, so they're blanks, so I don't have to worry about that. Now we have to do the walls now. So now, so I'm going to take a screenshot of that. All right, so now let's do the walls here. All right, so doing the walls now, I have to go letter for letter. So like for instance, let's go like a brighter color. Let's go like this yellow color. All right, so the first two is BC. That's the first two. That's the wall. BC. That equals the first two letters over here, RS. So in that case, I'm setting the 4W minus 7 equal to, because that's BC, that's equal to RS, which is the 2W plus 13 on the other picture. And I'd go ahead and I'd solve that thing out. If you did this correctly, I think your W ends up being a 10 if you did that one out. Then if we need to, we go plug it back in. Okay, is this making sense for how I'm doing these? How I'm setting up the walls and the angles and using the letters in the corner to help me figure out what to set equal to each other? Now, how would I solve for Z? Which two walls am I setting equal to each other to solve for Z? Z is the only letter I haven't solved yet. How do I set the Z's up to solve? What do you guys think? How do I solve for Z? Z is right over here, so you can see them. So what two walls do I have to set equal to each other? ED and UT, right? So it's going to be this one right here, D and E, and then T and U, right? It's the back two letters. It's the back two walls. So the back two letters make those two walls, and so I'd set the Z's up. 3Z plus 10, the Z plus 16, solve them out. Right? I think it ends up being a 4 or something like that. All right, questions on this one, though? Okay, all right. If this is making sense to you, that's pretty much the Google question of the day. Do you guys want to see the last one? Or you guys feel comfortable with what we're doing? Comfortable? Okay, you can go in your Google Classroom today. It's a Google question of the day. It's one question. You'll see it. It's a picture. Just click on the picture. It'll open up. You'll be able to see it. You have to solve. You have to find one of the walls. So you're going to have to find one of these letters like this, like an X or something or whatever they're asking, and then go plug it back in or whatnot. So,
do you have a limit?
yeah. Good. All right. For those online, still online, you guys can log off and go kind of work on your problems that you have. And I'll see you guys tomorrow.